So how long have you guys been in this building?
Probably 11 years.
11 years?
Yeah.
How long has U.S. Radiator been in business?
About 50.
50. I knew it was a long time.
I've been here 40.
40. You ain't old enough for that.
I started as a delivery driver of $2 an hour.
No way. And now you own the joint? That's a pretty good deal. You know, we like that. The American success story, you know? Yeah. Everybody in America thinks that ingenuity and work ethic and inventiveness and entrepreneurial spirit is gone. Okay, we've all been brainwashed into believing that. But these are the kinds of businesses that made America great, and they're still going on, which is why the name's pretty appropriate. How long have you been making your own cores? Forever? I mean, is that okay?
Yeah, that was the purpose of being in the factory business as opposed to the radiator shop business.
I got ya.
We buy raw materials and we machine it. We build the machines that we need.
Right.
Or we buy used machinery and retool it. And that's pretty much how we've done it over the years. This is where we stamp our tanks.
Okay, and you do stamp them all yourself?
We stamp everything.
That is bitchin', whether they're brass or aluminum.
These machines are dual form dies. These come from England.
Okay.
They're very expensive.
Yeah.
And they're duplicators.
Wow.
By punching that over and over and over again, and we make 150 to 200 stamps before we melt it down and do the next one.
Do it again, yeah. So that the quality never goes away.
Right.
Like this is a 63 or 4 Impala tank, but with different tanks that are different depths and all that, you have to use different thicknesses or different alloys of brass.
If it's going to be a deep draw, or if it's going to go into an industrial application, these tanks here, these are thicker. Feel that? That's a real heavy.
Oh yeah.
Compared to the automotive.
Right.
Because there's no ribs in it.
Right.
The ribs give it strength.
And without the ribs, then you have to go with a thicker material in order to get that same
Same
strength.
with aluminum. Aluminum
Aluminum
has to be real thick. Aluminum is very, very flimsy compared to brass. It's lightweight, it's flimsy, it'll have a tendency to distort,
right.
And we want to make sure we don't thin it out in any spot where we've drawn it.
I got ya.
That becomes a problem.
This is cool. Oh, that looks like a valve cover for an old Ford Y block.
Yeah.
Right? Yeah.
312.
So as all of these parts come through, as it goes through the process, I'm assuming each component gets put together till it gets to the welding or soldering or whatever.
Exactly. So this particular work order is coming here for him to assemble all the parts, for our guys to put the assembly. Here he's stamping the hose connection one at a time.
All with an arbor punch.
All with an arbor punch. Everything's handmade here.
How long has Ramon been working here?
We started at the same time, 40 years ago.
40 years ago.
Same month.
He was building radiators and you were delivering parts.
Exactly right.
40 years. And look how young he looks.
All right, let's go to the core department. Coils of copper. Comes through flat. Goes through these rollers.
It reminds me of the belt of bullet, you know, that the Mexican bandito would have. I don't know what it is. Women would like this. This is fashionable. See, is this slimming on me?
Fashionable.
Yeah.
This is their half-inch standard automotive fin.
Right.
This has been around since 1958. We still use a lot of it today. People replacing the older radiators with everything that's stock. We still use a lot of it.
But you've now come...
In the 80s, the industry figured out that by making a smaller fin, we get more tube and fin in a core, we get more heat transfer, more temperature drop.
And so then everybody went to 3/8 is what you said, right?
Everybody, well, all the manufacturers did.
Okay.
We've been able to take it and apply it to the older model where it wasn't available before.
To make a more efficient radiator in the same exact package, basically.
In the same dimension, height and width.
Now you also have a new one that only uses a 1/4-inch fin. That's your ultra high performance setup. Is that right?
We've had that for about 15 years too. Anytime somebody says to me, I got 600 plus horsepower or a blower motor,
Yeah.
we try to go that direction.
What is the increase in fin to tube contact with this
Double.
versus it's double over? Okay. I didn't.
Instead of a half-inch fin, you now have a quarter-inch fin. So where you have tube and fin before, you have twice as many with this.
Right. So that means that, like in this example, this is the half-inch. But if this was quarter-inch, there'd be more rows of these tubes, which means more fluid transfer and more heat transfer.
More heat transfer. The fluid isn't going to transfer anymore.
Oh, because your water pump is your water pump. It's doing what it's doing.
The gallons per minute is determined by the engine. How many heat transfer points we have in the core determines how much temperature drop we can get from inlet to outlet. The more ways for the heat to get out of the radiator, the more heat we dissipate.
Now, the half-inch compared to the quarter-inch, it's double the number of heat transfer points. Is it twice as efficient?
No.
Okay.
No. Unfortunately, we'll pick up 15 to 20% better temperature drop.
That's big. On a guy that's got an engine that's running, 220 degrees, 230 degrees, and he wants it to be down at 200, well, 10% is 20 degrees.
There you go.
So there, you're right there.
Yeah. There's a point of no return. I mean, we can't go any smaller. In fact, when we go this small, you want to make sure that when they went to these smaller fins in late model cars, you notice now when you open the hood on your daily driver, you can't see the radiator. They have shrouded it and designed the airflow so tight and so compact that they can use this and not have a problem with it. Back in the old days, you opened the hood on a 65 Impala and you saw the radiator, you saw the fan blade out there.
Yeah.
You know,
in the breeze, no shroud, no nothing.
Not anymore. Everything has to be more efficient in order for it to work. But this is a solder coated brass tube.
Okay.
Got a thin coat of solder on it.
So that it acts as flux in essence.
So it acts as the bonding agent between
the fins,
the tube and the fin.
So that's how, anybody that's wondering how a radiator gets built, you can't obviously get in there and solder every one of these to every one of those. So as a whole core, it's getting heated and therefore soldering itself.
All at once. And he stacked the fin and he stacked the tube. Fin, tube, fin and tube. Depending on what it is he's making, he knows how many of these he has to make. And he puts a clamp on it so that all of this is now held in place. These are unsoldered.
Unsoldered, which is why they're in the clamps.
Right. The other item that goes on here is going to be the end cap, or what we call a header. And every style of core takes a different style of header. This is a bucket header, for example.
Oh, I see.
That's going to go on a 57 T-Bird, for example. That's what that is.
I know those radiators.
It has to look like a 57 T-Bird.
Well, yeah, because your customer's not going to buy it if it doesn't look like the right one just because it bolts in.
They want the original look. They would like, but this one, if you can see, you see the number of tubes in here?
Oh yeah, that's real close. So
that's
this
real
is
close.
for the quarters.
So this is high performance. This is the T-Bird that's probably got a big block in it, or somebody's made a real performance car out of this bird. We got to give them the cooling. It's going to look like a 57 T-Bird radiator, but it's going to cool like whatever
like
you need
the
to
most
cool.
modern, best deal.
Right.
We can roast marshmallows in here. Real good.
It takes 20 minutes to make the pass.
You guys send a pizza through ever? Seriously, a pizza? That's a pizza oven. Okay, sorry. So it takes how many minutes?
About 20 minutes to get
20
through.
minutes. And is that one still hot?
No.
Because you know my propensity for burning myself.
Yeah, I touched it. So it comes out, and now all of these fins, see, he can take the clamps off. All of these fins are now bonded to the tube. Then the end pieces, where all of these little holes are, this is the problem. This is the problem area for leaking. So,
oh, I got you.
While it's a real good fit to begin with, it needs to be soldered. So that's what he's doing there.
That's what he's doing, is soldering all those tube ends? That's cool. It's not only soldering the tube to the plate up here, but it's also flowing inside to reinforce it from both sides.
Right. The weakness in a radiator comes from vibration, automotive vibration. Vibration affects this whole seal. It comes from the tires, the bad suspension, we need to be able to overcome that vibration, and this joint is critical.
Yeah.
And so to do that, we solder both sides, and you see that there's a little bit of solder on the fin as well down low. This gives it more strength where it needs it the most. The only other part of a radiator now is the side bracketry and all of the material that makes it fit one car versus another. Along that wall are all of the prototypes and samples of the original side brackets for the 600 different radiators that we make.
And it's 600 radiators.
Just about.
And so those are the templates for every one of them, and they're all made right here in this little sheet metal area.
So he's taken the pieces, he's put them all together in the way that they needed to go. Once he's done, he's soldering everything here. Once he's done, then he pressure tests it.
Okay.
It goes down to the other end of the shop where it gets cleaned, dried,
Then painted.
inspected. We inspect it before we paint it. All right, so we went through the section back there. Let's go into the aluminum.
So your aluminum radiators, your cores are made off-site for those.
Off-site for those. Where we do the cores over here in copper and brass at 400 degrees, these are done at about 1,000 degrees.
Okay.
Aluminum melts at 1,000 degrees. Solder
So
melts at 350.
In order to get the bond between the fins and the tube, you gotta go crazy temperature.
And to keep this from turning into paper, just
Yeah.
ash,
Yeah.
it has to be very controlled. So
And-
these are made off-site in a very controlled oven. All the other components are made here. We die stamp the tanks. We make the hose connections. We die stamp this little piece. This is for a Corvette,
Oh, okay.
62 Corvette.
And then every one of them is TIG welded. No epoxy.
Every one of them is TIG welded. There's no epoxy anywhere on this aluminum radiator.
So if somebody else is sitting here watching this and they want to buy a US radiator, how do they get one?
You name all of the big catalog suppliers who specialize in all the parts for that particular car, and we pretty much sell all of them.
And I assume they can go to the usradiator.com website as well and check out your dealer network and see if there's somebody local in their area.
They
if
can
they
check
need
out
it.
the dealer network. They can also look at the different radiators, because we give them all the information that I've given you here today, so that by the time they call their dealer, they know exactly what they want.
Very good.